Then comes halogen substituents. We know that fluorine, chlorine, bromine, and iodine are the halogens, okay, because they have a valency of +7. So if, for example, if I take this 1-bromo 3-methyl butane, so butane is the main structure or the root chain, okay, and at first position there is bromo substitution, at third position there is methyl substitution. If the halogen is bonded to a simple alkyl group, an alternative alkyl halide may be used. Okay. So, like if it is attached to an alkyl group of butyl, okay, a 4-carbon chain. So, alkyl halide like bromo butane, alkyl halide. Okay, butyl bromide. I can say like this. Thus, C2H5Cl may be named as chloroethane. Okay, chloroethane. No, because there is no substituent at the third. Like in the 1-bromo 3-methyl butane, there was at third position methyl substituent was there. But if there is no methyl substitution, only halogen substituted alkyl group is there, then I can name it as alkyl halide. Alkyl group attached with the halogen. Alkyl halide, ethyl chloride, propyl chloride, butyl bromide. Halogenated alkyl substituent such as bromomethyl and trichloromethyl. Trichloromethyl will be 3 chlorine groups will be there. And we know that hydrogen is having a valency of 4. So 3 valencies will be taken by the chlorine group. So formula will be CHCl3, may be listed and are alphabetized according to their full names. Okay. Then comes cycloalkanes. Okay. Cycloalkanes have one or more rings. Okay. Cyclic structure is there in alkanes. Okay. They can have one or more rings of carbon atoms. The simplest example of this consists of a single unsubstituted carbon ring. Okay. Unsubstituted because these are the cycloalkanes moiety are there. So they cannot be substituted. And these form a homologous series. So in cycloalkanes, the structural formula will be CnH2n. The IUPAC names of the first 5 members of this series are given. Okay. So here we will use the general formula of CnH2n, where N is the number of carbons. Okay. So like this, cyclopropane is for 3-membered, butane, cyclobutane is for 4-membered, pentane is for 5-membered, hexane is for 6-membered. Just now we read it. This in alkanes also, heptane for 7-membered. Similarly, cycloalkane CnH2n is the basic structural formula where N is the number of carbon atoms. Substituted cycloalkanes are named in a fashion very similar to the use of the naming branched alkanes. In a similar way, we can use the cycloalkanes nomenclature. The chief difference in the rules and procedure occurs in the numbering system. Since all carbons of the ring are equivalent, a ring has no ends like a chain does. Okay. The numbering starts at a substituted ring atom. So, these are the IUPAC rules for cycloalkane nomenclature. For a mono-substituted cycloalkane, the ring supplies the root name and substituent group as usual. Okay, so I will mention that I mentioned already. Like the root name is there, cyclopropane, cyclobutane. A location number is unnecessary because location number, why it is unnecessary? Because there are no substituent. So it will be the same thing if you repeatedly give the location number. If the alkyl substituent is larger or complex, the ring may be named as substituent. Okay, if there are alkyl substituent in the large or complex manner, then the ring can be named as a substituent group. So, like if more complex group like substituted methyl or ethyl group has been attached, then we have to name that particular ring by giving priority to that substituent which has been attached. If 2 different substituents are present on the ring, they are listed in alphabetical order, and the first cited substituent is assigned to the carbon. Okay, and the numbering of ring carbon then continues in the direction clockwise or anti-clockwise that affords the second substituent to the lowest possible location. We have to give the priority that the substituent should come at the lowest position. Like here, if I say that I'm giving priority to the carbon. Okay, first of all, I'm giving priority to the carbon and then I will give priority to the next substituents, which is to the nearest to that particular thing. Like over here, if I will give this priority as tertiary butyl cycloheptane, so I will start my numbering from here on. Okay. Prefixes if, di, tri, tetra are used to designate several groups of the same kind and are not considered when alphabetizing. Okay. When I'm giving alphabetical order, but still they won't be considered if I am using similar kind of groups. Like if there are three methyl groups attached over here. So what I will do? Tertiary butyl cycloheptane. Why? Because this is a 3-degree carbon, because this center carbon is attached to 3 different carbons. That is why this is tertiary butyl cycloheptane. Okay. And over here, this is a cyclic structure of a 7-membered ring. That is why it is cycloheptane. Okay. So tertiary butyl cycloheptane. Here, the basic ring is 4-membered. That is cyclobutyl. And why this "-ile" come? Because this is an alkyl group and it is attached to a different moiety, which is the 5-membered ring, where at the 4th position, 1-methyl substituent is there. So this will be 4-methyl pentane. If you will say that why we didn't give this as the 5th position, so the thing will remain the same, because then this will be the methyl substitution at the 4th position. So this will become the same if you give here the 5th position of the methyl group. So 4-methyl pentane will be there. So this structure will be 1-cyclobutyl 4-methyl pentane. So in the first case on the left, we see a 7-carbon cyclohexyl group was there, cyclohexane, bearing a C4H9. Okay, butyl substituent was there. Earlier, this substituent was identified as a tertiary butyl group. Okay, this substituent I just mentioned that secondary butyl, isobutyl, tertiary butyl are there. So a name based on cycloheptane root is easily written. In the second case on the right, a 4-carbon ring is attached to a branch 6-carbon alkyl group. Okay. Here, this 6-carbon branched group is there, but you cannot make it hexane. It is 4-methyl pentane. Okay. So, a 4-carbon ring is attached to a branch 6-carbon alkyl group. This C6H13 group can be named as isohexyl. Okay. This can be named as isohexyl. Okay. Because at the 4th position, there is substituent, methyl substituent, and that group is called as isohexyl group. Okay. But a better approach is to name this compound as a disubstituted pentane. Okay. What we did here as disubstituted pentane. Why a 2 substitution? Because 1 methyl substitution at the 4th position and 1 cyclobutyl substitution at the 1st position. But a better approach was this. Okay, that substituted pentane was a better approach. The 4-membered ring substitution is called as cyclobutyl group. Here I know that at the 1st position, the 4-membered ring, cyclic ring is there. That is why I added cyclobutyl. Now comes to the alkenes and alkynes. Alkenes we know carbon attached to a double bond is alkenes, and alkynes are carbon attached to triple bond. Okay, so here are the basic formulas which I mentioned earlier. CnH2n plus 2 is for alkane, CnH2n is for alkene, and CnH2n plus 2 is for alkynes. Alkynes are having a triple bond structure, alkenes are having a double bond structure, and alkane is having a single bond structure. Okay. So alkenes and alkynes are hydrocarbons which have carbon-carbon double bond and carbon-carbon triple bond functional groups. Okay. So molecular formula of these unsaturated hydrocarbons. I know that alkenes and alkynes are the unsaturated hydrocarbons which reflect the multiple bonding and functional groups. Okay. So each hydrogen is reduced by 2 with single double bond. Okay. So each triple bond reduces the number of hydrogens by 4. Okay. So as noted earlier in the analysis of molecular formula section, the molecular formula of hydrocarbon provides information about the possible structural type it may represent. Okay. So like if I have the molecular formula of C5H8 and the molecular formula for alkane will be C5H12. Okay, so here is the reduction difference in hydrogen content as 4. And just now I told that in the case of triple bond, in the case of alkyne, there is the reduction by 4. Okay, so this is the case of alkyne. Pentane is C5H12, so the difference in hydrogen content is 4. This difference suggests such compounds may have a triple bond, two double bonds, a ring plus a double bond, or two rings. Some examples are shown here, and there are at least 40 atoms. Okay. So, like the difference suggests such compounds may have a triple bond, two double bonds, a ring plus and a double bond, and two rings. So, this is for alkyne. Alkyne is C5H12. So, like this, IUPAC rules for alkene and cycloalkene nomenclature. The "-ene" suffix ending indicates an alkene or cycloalkene. The longest chain, "-ene" is for alkene when we are having a double. The longest chain chosen for the root name must include both carbon atoms of the double. The root chain must be numbered from the end nearest double bond carbon atom, and if the double bond is in the center of the chain, the nearest substituent rule is used to determine the end where numbering starts. Okay, so here we know that alkene is having a root or the ending with the "-ene" structure, and alkyne are having the ending with the "-ine" structure. And the longest chain chosen for the root name must include both carbon atoms of the double bond. Okay. So if I'm like double bond is there, taking two carbons, so I have to include both the carbons as the root chain. And the root chain must be numbered from the end nearest to a double bond has to be given the priority. And in the center of the chain, the nearest substituent rule is used to determine the end where the numbering starts. The smaller of two numbers designating the carbon atom of the double bond is used as the double bond locator. Okay. So if more than one double bond is present, the compound is named as diene, trine, or equivalent prefix indicating the number of double bonds, and each double bond is assigned a locator number. Okay. So if like two carbon atoms are there, both are having a double bond locator. So the more than one double bond is present in the compound is like if two double bonds are present at the second and the fourth position, then I will name it as diene. If three double bonds, then trine. And equivalent prefix will be added, indicating the number of double bonds, and each double bond is assigned a locator number. So I will name that particular. So like in cycloalkenes, the double bond carbon are assigned ring location 1 and 2. Which of the two is maybe determined by the nearest substituent rule. Okay. So, right here, vinyl group is there when one double bond is there, and allyl group is there when this double bond is attached by a alkyl group or methyl group. Okay, so this is allyl. So now IUPAC rule for alkyne nomenclature. Alkyne is C triple bond C. The "-ine" suffix indicates an alkyne or cycloalkyne. Cycloalkyne is when the C triple bond C is attached with a cyclo group. Okay. So the longest chain chosen for the root name must include both carbon atoms of the triple bond. Okay. So like if I am mentioning any heptane ring, that's a 7 number. So I should include that root name with "-ine" heptyne. Okay. Heptyne has to be the root name. The root chain must be numbered from the end nearest the triple bond carbon atom. If the triple bond is in the center of the chain, the nearest substituent rule is used to determine the end where numbering starts. Okay. So the root chain must be numbered from the end nearest to triple bond. Like in the double bond, in the case of alkene, we used to give the priority to the double bond. Same is the case with the triple bond carbon atom. If the triple bond is in the center of the chain, the nearest substituent rule is used to determine the end where the numbering starts. Okay. So in the starting, I have to give to the priority to the alkyl moiety. The smaller of the two numbers designating the carbon atom of the triple bond is used as the triple bond should be given the priority. Okay. So like if carbon atom is given at the second position or at the fifth position, there are the numbering in the heptane case. Okay, so at the second position, I will take this from the left side. If several multiple bonds are present, then what we'll do? Each must be assigned a locator number. We have to give the proper meaning. Double bond precedes triple bond in the IUPAC name. Double bond should come before the triple bond precedes, but the chain in the numbered form from the end nearest to multiple bond regardless of its nature. But the chain will be numbered in the end nearest form. Okay, multiple bonds like double bond, then triple bonds like that. Okay, because the triple bond is linear, we know that the shape and the hybridization is sp with the linear geometry with the 180-degree bond angle. So triple bond is linear with the sp hybridization. It can only be accommodated in rings larger than 10 carbons. Okay, so how it can be accommodated? It can be only accommodated in the rings having rings larger than 10 carbons. In simple cycloalkynes, the triple bond carbons are assigned ring location as 1 and 2. Which of the two may be determined by the nearest substituent rule? Okay, so like if several multiple bonds were there, double bond was given priority due to the triple bond. So like this, substituent groups containing triple bonds are ethyl or propagyl. Okay, so like this, ethyl moiety is there for the mentioning 2 carbons, and ethyl is there for 2 carbons, and nil is for telling us that triple bond has been present by N. Okay, so propyl group is mentioning that triple bond has been there. Over here, I have taken one illustration so as to cite you the example of 2,5,5 trimethyl 2-hexane. So we know that hexane is the main group, which is the branch chain or the loop chain, with having a substitution at second, fifth position. So at the fifth position, there are substitutions of 2-methyl group. Okay, and hexene is there. So at the first position, 2-hexene is there. So at the second position, there is a double bond, and 2,5,5 at the second position, there is methyl group. So I hope this structure has been clear to you. The compound has a double bond, making it an alkene. Okay. So like here they have mentioned the structure and you have to draw the structure. Like they have mentioned the structural formula and you have to draw the structure. So the compound has double bond, making it an alkene. Here the longest chain consists of 6 carbons. Okay. Longest chain over here is of 6 carbons. So the root name of this compound will be hexene. 3-methyl substituents are present. Okay. So like 3-methyl substituents, where they are present at the second position and at the fifth position, 2-methyl groups are there. Numbering the 6 carbon chain begins at the end nearest the double. Okay. So this numbering, how this numbering has been mentioned. This begins at the end nearest the double bond, i.e. at the left hand. Okay. So at the left hand, you have to number the groups, methyl groups at the fifth position. Now I have taken the second illustration, which has been for 2-propyl 1-pentane. Pentene shows that alkene is there with the 5-membered structure. At the second position, a propyl group is there. Okay. This structure is pentene with the 5-membered structure is there. So longest chain incorporating both carbon atoms of the double bond. This structure is quite different because what happens over here, the longest chain incorporating both carbon atoms of the double bond with the length of 5. So in case of pentene I'm talking about, this is the structure which has been drawn over here. Can you name the structure? This is having a 7-membered ring structure. 1, 2, 3, 4, 5, 6, 7 and 8. 8 is for octane. And if we take the positioning numbering of this bromo group, this will take as ethyl bromo. Okay. This will take as 1,1 dibromo ethyl. So 1, 2, 3, 4 and 1, 2, 3, 4. So this won't matter if you do the numbering from the left and right side, because this 2-2 dibromo ethyl group is coming at this 4th position from both the ends of the octane. So how we will number this as 4 at 4th position 4 dibromo ethyl octane. Okay, this is how we are going to number this. This is what is called the nomenclature. Okay, so now I'm telling you to derive the structure of all these compounds. Okay, so 2-chlorohexane. 2-chlorohexane is a very easy because hexane is the branch or the root chain which is having a 6 carbon in the basic molecule. Okay, so when you will draw the 6 carbons and then you have to add a functional group which is chloro at the second position. So the structure of the compound will be like this. Okay, it can be a straight chain, it can be a dash structure. So like this at the second position, 2-chlorohexane will be there. Okay. Now, second question was pent 4 in to all. Pent 4 in to all. So the basic moiety over here will be pentane, 5-membered structure. But ene is there. Ene shows that double bond has been there at the first position. Okay. Pent 4 in to all. 4 in shows that at the fourth position, I have to apply a double bond. Okay, so if I start the numbering from here, 2 all and 3 and 4 at fourth position, there is in. So this shows that pent 4 in to all. Now next comes the cyclohex 2 in 1 all and 3 nitrocyclohexene. 3-nitrocyclohexane is having a structure like this, where at the third position it will be 3 like in cyclohexane. If I start the numbering at the third position, I have to give the numbering to the nitro group. Okay, so like this structure will have is having a COH hydro carboxylic group extra over here. So but if I start the numbering from here 1 2 3, this will be 3-nitrocyclohexane. Okay, and then comes cyclohex 2 in 1 all. So, as the name indicates, the compound is cyclic with a double bond and a nitro OH functional group. Okay. So, the compound is cyclic. Over here, it's a cyclic compound. And 2 in. At the second position, I have to give in a double bond. Okay. And at one position, there has to be all. There has to be alcoholic group, functional group. So, this was the nomenclature of alkanes, alkenes, and alkynes. Right now, we just discussed about the various molecular formulas and the nomenclature rules and some of the illustration which are necessary so as to apply these IUPSC nomenclature. Hope to see you soon in the next lecture in which I will continue the further part. Thank you so much.